Here's a bonus example for Module 2, Lesson 2. And this bonus example is a question that you're going to get in MyMathLab. And I get a lot of questions about it, so I just thought, let's just do an example of it, and then maybe you can try doing it on your own during your homework. So this bonus example reads, one projection of the world population by the United Nations, in parentheses, a low projection scenario, is given in the table below, or I guess over here to the side. The data can be modeled by y equals, where y is in millions of people. And x is the number of years after 1990. In what year after 1990 does this model predict the world population will reach 6,702,000,000? Okay, so there's three big reasons why we missed this question. The first is they give you this table in the problem, and first off, don't even worry about it. You don't need this table. What I am guessing is they use this information here to make this regression, is what I would have to guess. But for us to solve and answer this question, we don't need this table here at all. So don't even pay attention to it. Second thing is that y is in millions of people, and then they give me this big number right here in billions. So what you need to do is, if this is in millions, you need to take this number and divide it by a million. So 6,702, and then 1, 2, 3, 1, 2, 3, divided by 1, 1, 2, 3, 1, 2, 3. Okay, and we get 6,702. So when I have this number here, knock off those back zeros right there. We don't need them. So if I'm wanting to know in what year after 1990 does this model predict the world population to first reach this number here, this is what I need to substitute in here for y. So now this number here is what we are putting in here. So I get 6702 equals my equation. Okay, now I can see it's a quadratic because of the x squared. So now we need to get this into standard form. Because we're going to solve this by quadratic, now I'm going to try to do this with these decimals by factoring. Because I'm going to use the quadratic formula, it's okay for my x squared to be negative. So what I am needing to do is move this over to this other side by subtracting. So I am going to, and it's like term, is this one right here, and we're going to subtract it from that number. So I'm going to get 0 equals negative 0.36x squared plus 38.52x. And now let's see what this number here is. We have 5822.86 minus this number here. So we get negative 879.14. Okay, so here is my quadratic. So my quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What are my a, b, and c here? My a is negative 0.36. My b is 38.52. And my c is negative 879.14. So input those into your formula. And it's going to be long because we got long numbers, but that's okay. So negative b is negative 38.52. plus or minus 38.52 squared minus 4 times my A times my C and that is all over 2 times A. Okay. So clean that up. My negative 38.52 comes down. My plus or minus comes down and have the square root of something all over 2 times negative 0.36 is negative 0.72. So let's put what's under that radical to see what we get here. So okay, I'm just going to write all those decimals down. 217.8288. Okay, so now let's get our two answers. I'm going to go ahead and put a box around this, but that's not my final answer. So from here, I get that x equals negative 38.52 plus my square root all over negative 0.72. And so we're going to get x to be about what? So I'm going to use my n over d here. So alpha y equals n over d. So we get about about 33. Okay. And now my second answer would be x equals negative 38.52 minus my square root. X is about, and all I need to do is arrow up and edit that. So that's roughly 74. Okay. Now, it wants to know when will this model first predict the population to reach. So first will be this one right here. And so that means if my X is after 1990, I need to do 1990 plus 33. So we are talking about in the year of 2023. Now I have a note to round up on this. And even though this one is so close to 33, right? 33.001. It still might say because we have gone all the way through that 33rd year and now we are 0.01 into the 34th year, it might be 2024. So if that number doesn't work, and specifically, it might not be as close to this, but if it wants you to round up, always go up to the next whole number. So it might be, in this case, 2024, but I would try this one first. You get 3 attempts, and so if it's not that one, try this one. But this one's hard for a couple reasons. One, just a bunch of decimals, but it's still the same exact process. 2, you need to make sure to mark off the last 6 zeros here. The answer is the first, so not the second number, but the first number that we get in. Let me reiterate, it's not because I punched this one in first. This one happens in 33 years. This one happens in 74 years. I'm wanting the lower number. And then it's also confusing because they give you this table, but we don't need to do anything with it whatsoever. So there you go.